Hello, let us continue our discussion on the high-speed designs. So, in this video, we will talk about the losses associated with the high-speed signals when they travel on a PCB. A very important topic, right? So, PCB basically plays a very crucial role in the high-speed designs. So PCB design parameters considered specifications that we have to follow for a given high-speed signal are very important. And if a small deviation from a specification, if there is a small deviation from the specification, there could be a drastic change in the performance of the signal over that channel. So very crucial that we follow critical guidelines in the PCB design. Now that's about the PCB design, but we are talking about the PCB here. So when high speed signal is traveling from the source to the destination or the driver to the receiver, the PCB should not contribute to any losses in the signal. So what is there between a driver and a receiver? There's a signal trace, right? And then underneath or the inner layers or between the layers there is a dielectric associated. So the signal travels on a PCB trace, and that trace could have some losses, right? So the dielectric also could have some losses. So considering that point, in reality you don't have a zero loss PCB. You will have some or the other losses as we are talking, like it could be loss in the PCB trace or loss due to the dielectric. So, if we categorize those losses, the two main losses associated with the PCB are conduction loss and dielectric loss. So, conduction loss is due to the I square R losses in the PCB traces. So, this is a very crucial loss. So, your PCB traces definitely have some resistance associated, and when we flow the signal or when the signal flows from driver to the destination, there will be losses. So these losses cannot be controlled by us. So if you have a PCB that is routed for a specific impedance, you have to have a specific width and distance from the nearest reference plane, right? So in those cases, for a given width, there'll be a R associated with the trace, which could be very minimal, but still it is a loss in the PCB. And then the other losses, when we talk about a signal traveling from driver to the receiver, it is basically the electric field, varying electric field that will be seen, right? So these electric fields, when they travel over the trace, could have some heat that is being dissipated. So when heat is dissipated, basically it's the energy loss, right? So that means there is a signal energy loss that is associated, which heats the dielectric. So these points are very important, and these losses are called the dielectric losses. So two losses, which are conduction loss and the other one is called the dielectric loss. These two losses contribute to the losses of high speed signals in a PCB.